So in STP, the last one that we see is MST. Stands for multiple VLANs spanning tree protocol. Multiple VLAN in one instance of spanning, one instant. In the last one, which we saw rapid is good, it is fast, no doubt, but the process utilized is too high, which is unacceptable. When we have more VLANs, then only the problem is big. More VLANs, more STPs. And it is not normal slow STP, it's a fast STP, which consumes processor very high. So, what is necessary? We need to group VLANs under a single instance so that we can reduce the process utilization. When you simply enable MST, all VLANs will come under one STP, one STP. But this is not normal STP, it is rapid. I repeat, even though you enable MST, what gets enabled is rapid. Then what is the difference? There you have multiple instances of rapid. Here you just got only one instance of rapid for all VLANs. Additionally, it provides the flexibility of creating more instances as much as you want and map some VLANs to each instance. So for example, when I enable MST, there is a instance called MST0 gets created, and whatever the VLAN that is running on the switch, all VLAN gets mapped to this instance. So only one instance of MST for all VLANs, and it is rapid. But when you have only one instance, you cannot do load sharing. If I have this type of topology, which you usually have for understanding load balancing, when we have this type of design, and if there is a block here, all VLANs are now going to go via this way only, and this path is totally idle. So in order to do load sharing, we need two instances at least in this scenario. So what I can do is I can create MST1, MST2, and let's say I have 20 VLANs. I'll have VLAN 1 to 10 in this instant and 11 to 20 in this instant. We have only 20 VLANs. I don't have any members for these VLANs, this range of VLANs, so this will not be active. Only two MSTs are now going to be active. Now I'll go and use all the technique. MST1, spanning tree MST1, root primary. You remember? We used command primary.
Yeah, root primary and root secondary.
MST1, I'll say root primary here. MST2, I'll say root secondary. Sorry, root primary. MST1, I'll say root secondary. Here MST2, I'll say root secondary. That's it. So we need at least two instances in order to do load sharing. So all these 10 VLANs will go via the upper path. All these 11 to 20, 10 VLANs will go via the bottom path. But we cannot say it is whether we are not really equally load balancing. We don't know about the load. The load of VLAN 1 to 10 may be very high, maybe 75%. The load of 11 to 20 traffic may be only 25% of the entire traffic. So we cannot say equal cost, we cannot say equally share the load. We are just sharing based on the VLAN numbers, that's all. We don't know how much percentage. Maybe the users in VLAN 1 to 10 may be very much more, very high. Users in VLANs 11 to 20 will be less. So who knows? So we can say we are load sharing, but not equally. We are doing some load sharing. Instead of keeping this path idle, we are sharing the load. If you want to share 50% of load, then you need to do some study and see how many VLANs I need to put here to have 50% so that I can take the remaining 25% and add it to this. So what all VLANs I need to push from here to make it 50-50. Yeah. So that needs to be done. The study needs to be done. Then you will have some sort of, not accurate, some sort of load sharing with equal amount of load. This is what we are going to do as this first lab. After this, we will learn VTP version 1, version 2, version 3, and then in version 3 we will include this MST. There is some connection between version 3 VTP and MST. MST and VTP version 2 are not compatible. MST with MST with VTP version 1 and 2 are not compatible. Version 3 is compatible. We'll see those things step by step. Let us first MST.
Yeah.
So let us see what is configured already in this port switch. First, let us go and verify what is there. When I go to switch 1, I type show spanning tree detail. I can see here it is IEEE compatible spanning tree. And when I simply type like this, okay, port first is enabled. So this must be RSTP show run section spanning. Okay, sorry, it is per VLAN spanning tree. Let us
Span
now
tree. Yeah.
switch to MST. But when you are configuring MST, you need to configure port first. And I see it is already configured. Show run, you see interface, show run. Ethernet 0/2, I can see the port first is already, no, it is not. Sorry, in this port, E0Z, wrong. Yeah, port first is already enabled. So we need to make sure that all the host ports are port first enabled.
Yeah.
It is. All the access ports, all the host ports are port first enabled. Now, what is next? MST configuration. You see, spanning tree mode MST. When I type this, you can see show spanning tree. Uh, show MST. Let me type show MST. Show MST. Show spanning tree MST And we see for all VLANs, only one instance is responsible. But we don't want like this. We want to load share. Yeah. So what are we going to do? We're going to create
Create two
instance.
instances of MST.
Yeah. So we need to say spanning tree MST configuration. Now, right now I'm inside the MST mode. Here we need to give a name. Set the configuration name. It can be any name. I'm giving a name promise. Some name I need promise. And then I need to say revision number 1. Why is this revision number needed? See, right now I'm going to say instance 1 will take VLAN 1 to 10, 1-10. And instance 2, I'm going to say VLAN 11-20. But what if tomorrow I want to change my mind, I want to take VLAN 8, 9, and 10 and give it to instance 2. Meaning if I need to edit something to the VLANs that are mapped to this instance, then I need to increment the revision number to say a change has been done. When we don't do this revision number, when we don't increment the revision number, then the update that you have configured will not be active, will not be updated. The changes that you made will not be active. So whenever we do some changes to the existing MST configuration, we must
Yeah.
increment the revision number manually. Okay, so we have given a name, we have given 2 instance, we have also said revision number. That's enough. Let's go and verify. Show MST, show spanning tree MST, and you can see here MST0 has got the VLANs from 21 to 4094. Earlier it was from 1, now it is from 21. Anyway, we don't have those VLANs in our topology. And MST1 is responsible for VLAN 1 to 10, and MST2 is responsible for 11 to 20. Now let's move on to the other routers, the other switches. We finished switch 1, right? Yeah, switch 1 is over.
Yeah, switch 1.
Similar configuration, we are going to put it on other switches. So better copy to show history. Better, good to copy this. And I take it to a notepad. This is for the other class which we created. Now I'm going to alter. No, there is no need of alteration. What alteration is needed? Nothing.
Because it's the same
Yeah.
VLANs, isn't it, in both
Yes.
all the
Yes.
switches.
place. You just need to copy and paste it. Switch 2, switch 3. And switch 4. Okay, so we got 4 switches. MST configure. Let's go and verify where the blocking is. I'll start from switch 4. Show spanning tree for MST1. When I say MST1, it is for VLAN 1 to 10. VLAN 1 to 10. And Ethernet 00 is in VLAN 10. That is why we see here Ethernet 0. Ethernet 01 is not seen here because it is in VLAN 20. VLAN 20 is not part of MST1. MST2 is VLAN 20. So you have Ethernet 01. So there is no blocking here, and this is not a root switch. Root switch is connected via Ethernet 3, that's what it shows. So let us go and check the root switch. Switch 3, are you a root switch? Or switch 1, something. Switch 3, let's check switch 3. Show spanning tree for MST2. This is not the root. Root is connected via Ethernet 0. So switch 1 is the root switch. Before that, I want to check the other MST 1. Switch 3, MST 1. Actually, we need to focus on 00 and 01 interface, not on Ethernet 02 and 3. It shows Ethernet 2 and 3 because you have VLAN 1. VLAN 1 is a member of all interfaces that are not configured or member of VLAN 1. That's what it shows. Okay, now what I'm looking for is the block. I'm sure switch 2 is the blocking one, but let's go to switch 1 and check the root. This says I'm the root. This switch is the root for MST1. What about MST2? Again, this is the root for MST2. This one. This is not the one which we want. We want this to be the root for MST1 and this to be the root for MST2. But unfortunately, it is the opposite. Switch 2 is blocking. Show spanning tree for MST1, blocking. Which one is blocked? No, there is no block here. I think the block is here in Ethernet 02. Let's check. MST2. There is no block here. Then where is the block? Switch 4, is it blocking? Switch 4 is the one which is blocking in this port. For MST1 also it is blocking the same. So we need to do load sharing. As we already know the command, we are going to go to switch 2's spanning tree for MST1. This is the syntax. Spanning tree for MST1, root, primary. Spanning tree for MST2, root, secondary. Are you comfortable with this command?
Yeah, play that.
Let's check the switch 3 and Here also we'll say spanning tree. MST1 root secondary. Spanning tree MST2 root.
2 is root primary.
After saying this, let's give few seconds for convergence. And then we'll start from switch 2. On switch 2, when I check show spanning tree, MST1, I can see this is the root switch. And the priority is
Yeah.
this much. And switch 3 shows spanning tree MST2. This is the root switch. So what about MST1? MST1, this is blocking. MST2, it is root. MST1 is blocking. If you take switch 2, MST1, it is forwarding. MST2, it should block. Yes.
Block, yeah.
So for all this 20 VLAN, switch 2 is blocking. Here we see in detail. MS2 VLAN map is 11 to 20. It's the root bridge. MST2 is root forwarding on this interface. There's an alternate blocking. Okay, so this is it, MST configuration. Are you comfortable? VLAN trunking protocol. VLAN trunking protocol. See, the reason why we need this protocol is we want to configure VLANs on all switches with similar database, VLAN database. We want all the switches to have same number of VLANs, consistent, without any mistake, without missing any VLANs. VLAN that is created in one switch, we want to create on all the switches. Same way, when I delete one VLAN on one switch, I want it to be deleted on all switches. To make this job easier, we need a protocol. That is VTP. VLANs are replicated. You just create on one switch, it's created on all other switches. How? The VTP update. The VTP update that goes to the other switch tells the other switch to add the new changes to the database, VLAN database. You know, the VLANs are not saved in the running configuration. Have you ever seen any VLANs saved in running configuration?
No.
When you type show run here, we have created VLAN 1 and 2. See show VLAN brief. We have VLAN 10 and 20. I'm also going to create VLAN 100, name 100. VLAN 200, name 200. When you type show VLAN brief, you find them VLAN 100 and 200, but when you type show run, you will not be seeing anywhere VLAN 100 and 200 that we just created. You will not see. Where can you see it? It is actually getting saved to flash. Show
There's a colon at the end, isn't it, sir?
this operating system is designed for EVE. So
Okay. Try show flash colon, I think, sir. Show flash colon. Is it there? Oh, no, it's not. Okay.
anyway, so it is actually saved in a location called flash. Show disk one. Save. It is actually saved in a location called flash. This is assembled in the environment. It's EVE, so
Yeah.
they are saving to some files. They don't really have any flash. But in the real switches, it is saved to flash memory. The location where the VLANs are updated. Whenever you do changes to the VLANs, it gets updated to the flash. Whenever the flash gets disturbed, VTP will shoot out the updates. VTP will send the copy of the VLAN database as VTP update, and the receiving switch will receive those packets, get synchronized, and forward it to the downstream. So we need VTP to do these jobs. What? Replicate VLANs. And what is the reason for this word trunk? See, this VTP works only over the trunk ports, trunk links. In order to have VTP, two things are important. Number one, VTP domain name. VTP domain name helps us to define the boundary within which the update need to be flooded. If the domain name is same on all switches, then changes that you do on one switch will go to everyone whose domain name is the same. All the switches. If domain name is 123 on all the switches, then when I create a VLAN here in one switch, it goes to every switch whose domain name is 123. So replication of VLAN happens between all switches whose domain name is same. That's not enough. All the switches, the inter-switch link need to be a trunk link. That is why VTP, VLAN trunking protocol. The VLAN gets replicated over the trunk link. Two things, domain name and trunk. Optionally, you can have authentication, not mandatory. Now this VTP is of 3 versions. Version 2 is default, version 1, which was not supporting token ring. So they came up with version 2 to support token ring, but no one uses token ring today. So version 1, version 2, you no need to spend much time because there is no need for token ring. Version 2 supports token ring. Who wants to? So version 1 or version 2, that is okay. Version 3 is something unique. Version 3 supports authentication, secret, hidden, so on. Whereas version 2 supports only plain text authentication. Version 3 can support encrypted, hidden, secret authentication. Not only that, version 3 can replicate the MST configuration that you do on one switch to all other switches. There are much more which we need to see. When we go there, we'll see that MST version 3. But let us first, VTP version 3. Let us first of all understand VTP better first. We need to understand VTP. VTP, two things as I said, any version, whether 1 or 2 or 3, you need a domain name in common. Secondly, you need trunk links between the switches. Inter-switch links need to be a trunk link. I'm not talking about ISL protocol. I'm just using the word ISL to say inter-switch link. The wire that is connecting between the switches need to be a trunk. Say, for example, we have 5 switches. And by default, when you configure, see, these are all trunk ports. As in, we have already put the trunk port. As soon as you put a domain name here, the domain name also gets replicated here. Yes, the domain name will also get replicated, but there is a good practice. Whether it gets replicated or not, you need to go and replicate, you need to go and configure it. That is good for us. At least the domain name should be configured manually. The domain names gets replicated, but you need to make sure the domain name is configured. Next, when you configure VLAN on any switch, let's say VLAN 10, I say VLAN 10 on switch 3. All the switches on left and right will have VLAN 10 dynamically configured. But actually I configured it on VLAN switch 3. But it gets replicated to 5, 4, 2, and 1. Replication is dynamic. Now you can delete it from anywhere. You create it on switch 3. Right now you are not sitting with switch 3, but you want to delete this. No problem. If you are at switch 5, you can go and delete here. It gets deleted everywhere. And now when you create VLAN 20 here on switch 2, it gets created everywhere. How is this possible? When I created VLAN 10 on switch 3, how all of the switches know that there's a new VLAN? It is because of the revision number. VTP dynamically increases the revision number whenever a change done to the VLAN database. Initially, the revision number will be 0. See, when you configure VTP, if you have 100 VLAN, let's say you already have 100 VLAN, and you're going to configure VTP, what will be the revision number? 0. Because you had 100 VLAN, it's not going to say revision number 100 or something like that. It starts from 0. You may have existing VLAN. Don't worry, that VLAN will not get deleted. Will not get deleted. You see, I have VLAN 10, VLAN 20, VLAN 30 when I configured VTP here. That time, other switches do not have any VLAN. I'm just configuring VTP here. And then I moved here, and then I moved here, and then I moved. I configure VTP on every switch now. Will they all will have these VLANs? No. Why? Before configuring VTP on this third switch, you had this VLAN. So when you do some changes to the VLAN database, only then VTP can make some impact on the other switches. When these VLANs were created, VTP was not present. So even after creating VTP on all 5 switches, you don't see replication. It is because no disturbance have been done caused to database. Now when I go to so now the revision number is 0 everywhere. VTP is enabled, so revision number is 0. But I got 3 VLANs here when the revision number is 0 plus 5 VLANs. You know what are they? The default VLAN 1, and there will be 4 other VLANs. If you take any switch, you will have 5 VLANs there by default. So totally I got 8 VLANs. The other switches have got 5 VLANs, the default VLANs. Now I'm going to just go and delete this VLAN 30. When I delete, what happens? The revision number will get hampered. So it's going to become 1. When the revision number increments, immediately whatever is there in the database will be sent as an update. The receiving switch, what they do is, they compare the local revision number with the incoming VTP update revision number. Because the revision number is higher, they are just going to wipe whatever they have in the database and copy whatever that comes in. So in that update, you also have this 5. So 5 plus 2, 7 VLANs. VLAN 10, VLAN 20, and then the 5 default VLAN gets copied to the database. That is how the updation happens. Repeating again. VTP updates are not going to go and alter your existing database. VTP update with a higher revision number will delete your database completely and copy all that is coming in. After copying, this revision number gets incremented to 1. Same way, VTP 10, VTP 20, and revision number is 1. So everywhere the VTP with the revision number VTP VLAN 10, VLAN 20, 10 VLAN, revision number is 1. Though you are getting 2 VLANs, the revision number is still 1 because the VLANs got updated to the database in just one go. only once disturbed. Yes. So VTP VLAN trunking protocol helps to replicate if the revision number of VTP update is higher than the one which is in the local, the switch will delete all that it has got and copy all that is coming in. That is how VTP updation happens. It is the revision number that matters. So if you delete another VLAN, you can delete from anywhere. If I delete another VLAN, then revision number increases to 2. Immediately, this new change impacts everywhere. So all will make this VLAN database fresh, a copy. They're not going to delete VLAN 20 like I'm doing. It is not like that. It is going to just delete all and then copy whatever comes in. Increase the revision number. So this is how VTP can update VLANs. Now, there are 3 modes in VTP. The one which we are talking about now is called as the default server mode. We got 2 more modes, which is client mode and then transfer mode. What is the difference? In server mode, you can create, delete, modify VLANs. In server mode, you can create, delete, modify VLANs. And the VLANs are saved to RAM, means flash, not RAM, flash. They are saved to flash. Whereas in client, you cannot create a VLAN. You cannot delete a VLAN. You cannot modify even a name of the VLAN. And the client mode saves it in a temporary memory. Just in a temporary buffer. So when you turn off the client, everything, the VLANs, they all get deleted because client depends on the server for VLANs. Every time a client comes up, it gets the update from the server. It will not save the VLANs locally. But when you switch off a server and bring it up, the VLANs still there, get loaded. Servers need not to copy anything from the client when it comes up. But client, when you switch off the client, everything gets deleted. The VLANs get deleted. So they depend on the server for VLAN updates every time they come up. It is because they don't maintain the VLAN database. Client don't maintain. But what client can do is, after synchronizing its database, when a new update comes, after synchronizing the new update to the database, it will forward it to the other switches. To the downstream. Same way, if there is a server if there is a server switch on the way, server switch will also, after synchronizing, it will forward it to the downstream. For example, I have a server switch. I got a client, okay, another server switch, and in between I have a client switch. I got another server switch. I got another client switch. I got another client switch. So when I create VLAN 10, it impacts client, and client also forwards that update. That update is not generated from the client, it is just forwarded message. Because that forwarded VTP update has got higher revision number, the server will also get updated. After synchronizing, it will forward it to downstream. The server gets updated again. It is forwarding. Originally, it is generated where? Here. The others are simply distributing it. The clients get again VLAN 10. Again, they forward. It forwards. The other client gets. So what you understand from here? A client can get update from another client. Nothing wrong. It's not only a server should give an update. Client will also forward an update with a higher revision number which it received from the upstream. So the downstream will simply receive it. The downstream can be a server. For this client, the downstream is a server. So server can receive an update from a client. A client can also receive an update from another client. A server also can receive an update from another server. So I've just given here various options. These are all possible. Only the thing matters is the revision number. Whoever gives that doesn't matter. Is he giving a higher revision number update? I'll accept it. That is how it is. So the big difference between the server and the client is you cannot create in the client. As a result, clients cannot generate any fresh VTP update. Clients, they all receive from server and they synchronize their own database and forward it to the other downstream switches. The other point is clients do not save it to a flash. It is maintained in the temporary buffer, whereas the server maintains the VLAN information in a flash. Next is the transparent mode. This transparent mode allows you to create, delete, and modify VLANs. And this creation, deletion, modification VLANs, though they are saved locally to the flash, no revision number gets incremented. When you make it as transparent mode, the algorithm will not allow the revision number to get incremented. As a result, the transparent switches will never send any fresh VTP update. Not only that, because the revision number is not allowed to increase, if any VTP update comes with a higher revision number, that doesn't matter for the transparent switch. Because the transparent switch is totally ignoring the revision number. It never increments. I believe you understand what I'm saying. Transparent mode will not get synchronized with VTP update that is coming from other switches. Transparent mode will not send any VTP fresh updates when you do some changes to the VLAN.dat on this transparent switch. The reason is the revision number is always kept to 0. When there is no increment in revision number, there is no fresh VTP update goes. Even when a new VTP comes with a high revision number, transparent switch will not worry about it, care about it, because transparent switch are not supposed to increase the VTP revision number. As a result, if I'll have a transparent switch in the path, I have a transparent switch in the path. The VLAN that you created here goes to every switch except this switch, except the transparent switch. And when I add VLAN 30 here on this server, it goes to this client, it goes to this server, it goes here, but not to transparent switch. From this, what you understand, the VTP update that is coming to transparent switch will simply forward it to the downstream without synchronizing its own database. Without synchronizing its own database, it simply forwards it to other switches. Transparent switch neither generates a fresh VTP update nor synchronizes to the VTP update that comes in. Transparent switches will never increase the VTP revision number. The revision number will always remain 0. In the transparent switch, you can create, delete, modify VLAN, but whatever you do, it is going to be local, will not have any impact on the other switch. That is why they are called as transparent switch. So you see, whatever the change that happens here, that is reflecting here, which means the middle guy is a transparent. If the middle guy is not transparent, the reflection won't happen on the client. Whatever you do on the client, whatever that is done to the client will also reflect here. Say, for example, I have another server here. I'm adding VLAN 40 and 50. That goes here. That goes here. It immediately jumps here as well, which means this is a transparent glass. And this is like a mirror. Whatever comes here will get reflection here. That's why it is transparent switch. Now, I have a question. I want a member of this VLAN 10 to talk to a computer which is here. What should I do? I want A to communicate to B. What should I do? The switch to which B is connected is a transparent switch. Will I be able to communicate between A and B? No. Why? If you want to communicate to A, you need to be a part of that VLAN 10. So you need to create manually here VLAN 10. When you put this interface in VLAN 10, only then A can ping B. Now another question. Now this B is not here. And there is no VLAN 10 created in the transparent switch. B is here, connected to the switch. Will I be able to communicate between A and B?
Yes.
No. Why no? Because the domain, the broadcast domain VLAN 10 is missing in the middle switch. See, if VLAN 10 need to be extended, the switch should support. So unless you configure a VLAN 10 manually here, through replication, VLAN 10 will not get created in the transparent switch. When you create VLAN 10 manually, the VLAN 10 gets extended. So if you ping from A to B, it will ping. If you ping from A to C, it will ping. So make sure the switches in the path also member of the same VLAN, whether they are having member or not, whether they are having VLAN members or not. The VLAN should be there in the path. It's like, a bridge domain getting extended, a broadcast domain getting extended. So the VTPs are not responsible for your communication. You have to find a way to communicate. VTP's responsibility is just replication of VLAN info. That's all. There's nothing other than replication. So you have to see whether the broadcast domain is there in the path. If there is a transference switch, definitely the VLAN 10 will not be there. We have to put the VLAN 10 manually in order to ping from left to right via transference switch. So these are the three modes that we have: server, client, and transparent. Server mode is a default mode where you can create, delete, modify VLAN. Server mode switches can generate a fresh VTP update when you do some changes to the database. Not only that, when a server receives an update with a higher revision number, it synchronizes its own database, after which it will forward the update to the downstream. Client also forwards the VTP update that it received from the upstream to the downstream with synchronizing its own database. Transparent switch will also forward the update coming from upstream to the downstream, but it will not synchronize its own database. Transparent switch will not get synchronized to any VTP update that comes in. It will simply forward the update to the downstream without synchronizing its own database. Transparent switch will not synchronize its own database, but still it can forward the VTP update from the upstream down to the downstream. Transparent switch allows you to create, delete, modify VLAN, same like server switch. But the difference is server switch revision numbers increments every time you delete or create. Even when you delete VLAN, the revision number is going to get incremented only. Is going to get incremented only, even when you delete VLAN. So whenever change is done, the revision number increments. Whereas in the transparent switches, whatever the change that you make, the revision number is not allowed to get incremented. As a result, the VLANs that is created in transparent switch will not get replicated to other switches. Same way, when other switches sends in the VTP update, transparent switch will not get it synchronized because the revision number is not allowed to get synchronized. So whatever you configure manually local is what for that local switch. Yeah, so these are all the points about VTP. 1, 2, and sorry, 1, 2, yeah, and 3 as well. In VTP version 3, there is one special mode called root primary. Sorry, VTP server primary, not root primary. Server primary is another mode, a special mode which is seen only in VTP version 3. Whichever is server primary, only that will have the privilege of impacting others. I repeat, I repeat, I repeat. How many server switches we have in this picture in the front? We have 1, 2, 3 servers. But you cannot create on these 3 servers. Only one server per domain. I repeat. For security reason, we have server primary. Because you have 3 servers, what if someone goes to the server switch and keep deleting? In the client they cannot do, but in the servers they can do. When you have version 3, even on server they cannot do unless they know the password. Yes. To make a server as a primary server, they need the password. So version 3 is more secured. When you say server primary, it asks the password. When you put the right password, only then that switch will be a primary. Not only that, every other switch will get an update saying this switch is the primary one. So all other switches will listen to the primary. So when you make a switch as a primary, the MAC address of the primary switch will be given to everyone saying, if update comes from this MAC address, you can accept it because he's the primary server. So other servers will not be eligible to create or delete or modify. So there is a big difference between version 2 and version 3. In version 2, any server can be used to create, delete, modify. But here, only when you make a server as a primary, that server will have the privilege of impacting others. See, a server can be made as a primary, a client cannot be made as a primary. So that's the big difference between a normal server and a client. In version 3, you still have client and transparent. What is the difference between server and a client in version 3? Client will not allow you to create, delete, modify VLAN, that is true. Even server is not allowed to create, modify, delete VLAN. What is the difference? In server, I can say, hey, you be a primary for some time. By giving the right authentication password, I can make a server to be a primary server where I can do changes. In client, you don't have something like that. Client is always a client. It will always depend on others. It cannot be made as primary. So these are the big differences between these versions. Now we need to do a lab on version 1, 2, and 3.
Yeah.
So we are going to do VTP labs, and we got 4 switches, and all these 4 are going to be under one domain. Even though you have a redundant path, there won't be a duplication. You see, whenever I do some changes to switch 1, both switch 2 and switch 3 is going to forward a copy to switch 4. But the revision number matters. If switch 4 has taken update from switch 2, it is not going to take it from switch 3 because the revision number is same. So VTP, even in redundant path, is effective. There is no confusion. But I want to delete this wire. The reason is I want to have more switches so that I can do even transparent. Okay, so this is the topology. And we all know there is already VLANs. See, STP has got no connection with this as of now. We already have STP MST running. But there is no need of any STP here because we don't have redundant path. The only path between S3 to S4 is via S1 and S2. So that's not now important. What is important is the revision number. Let me show you the revision number and the current status of STP from switch 3. Show STP. Sorry, not STP. Show VTP. VTP status. When you say show VTP status, you can see this is in a server mode. The existing VLANs are 7. The revision number is 2, which means there was 5 default VLAN, and when I created VLAN 10, it became revision number 6, and when I created VLAN 20, it became revision number 7. Sorry, it becomes existing VLAN 7 and revision number 2. For each changes that you make, one revision number. Repeating again, I made some confusion in the words. When I created VLAN 10, the number of VLAN became 6 and the revision became 1. When I created VLAN 20, the number of existing VLAN became 7. The revision number became 2. Because the existing VLAN, if you see any switch show VLAN brief, you will find these 1 and these 4 switches by default. So four VLANs by default. We need not to create these things. It will be there already. Reservation for FDDI token ring is done, but again you see here it's unsupported. Cisco don't support all these things, but it is there by default, because as per the norms, any operating system from any vendor in a layer 2 layer 3 switches should have this as per the standard. As per the standard, it is there. Yeah. Okay. Now what is next? I'm going to create a VLAN 30, and now if you see VLAN 30 is created, and now if you see VTP status, the revision number has increased to 3, and the existing VLAN has increased to 8. But the replication of VLAN is not going to happen because there is no domain name. See, we do have trunk links in between switches, but domain name matters. Let me see. Go to switch 1 and see. You will not see any VLAN with number 30. Show VLAN brief. No VLAN 30. And then show VTP status. This is having a higher revision number. Revision number is 4. And there is no VLAN 30, whereas the other switch has got revision number 3 and VLAN is 8. The VLANs that is available here is 10, 20, 30. The VLAN that is here in the other switch is not the same. 10, 20, 100 and 200. So you remember in the initial stage I said VTP is to provide consistent VLAN database. Meaning you cannot have some extra VLAN in one switch. So either you should consider switch 1 as the authoritative correct database. Switch 3 is having VLAN 30, which is not seen in switch 1, and switch 1 has got 100 and 200. Switch 3 don't have it. So any one switch we need to make it as authoritative as of now. From there we should replicate VLANs to others. So I'd like to make switch 1 as the authoritative initially. After synchronizing, they all become one, same. Show VTP status. We see here the revision number is 4 and VLAN is 9, domain name is nothing. And the version that is running is version 1. I would like to switch to version 2. The command to do this is VTP version is 2. I would like to do the same on all other switches. Switch to VTP version. Switch 3, VTP version 2. Switch 4, VTP version. Okay, so we got VTP version 2 everywhere, and switch 4, show VTP status. Here we see 7 VLAN and 3 revision number, very small revision number here. And the VTP version, if you see, it's the same version 2. This is capable of version 3. We'll talk about version 3 later. Version 2 is the default in most of the case. So we are learning version 2. Now, as we already decided, we'll go to switch 1 and start our configuration. VTP domain, I would like to give a name as golden. That is the name that I would like to give as a domain name. And you see the golden name, the VTP name is golden now, from null to golden. Let us verify this. Show VTP status. I see the name golden here. Now let me create some VLAN. VLAN 888. And the revision number should have increased to 10. Sorry, 6. And VLAN's increased to 10. And I would like to check the trunk link. Show interface trunk. The interfaces connecting to other switches, both E02 and E03, are trunking. Now, what I'm expecting is this 888 should have been now reflected on the other two switches. Why? When there is a trunk port, even the domain name get distributed. So now when I go to switch 3 and see show VTP status, I see the domain name. I did not configure it on switch 3. And I see the VLANs 10, and I see now VLAN 30 gone. Instead, you got the VLANs from switch 1. This proves that it's not going to alter your VLAN database. It's going to delete and copy whatever comes in with a higher revision number. But it is a good practice always to provide the domain name manually. VTP domain golden. Even if it says already, it is okay. And let us go to switch 2 and see show VLAN brief. So this shows that even switch 2 has got the domain name auto configured. Let us go to switch 4. Even here I see the VLAN number increased, which means the domain name is also copied. Show VTP state, show VLAN brief. And you see all those VLANs duplicated here. So now all the switches are synchronized. In this condition, if you go and check show VTP status, the message digest must match with all the switches. Switch 4 has got this as the message digest. See the last number B9 and 8B. So let's keep this 2 and go and verify on switch 2. Show VTP status. Yeah, same P9 and 8B. Let's go to switch 1 and check. Show VTP status V9 and 8B. Let's go and check on switch 3. Show VTP status. So this is where we start our troubleshooting. If question says, hey, there is some problem with the VLAN replication, boom, okay, VTP is the problem. Where in VTP the problem? How do you identify from where to start? First, you go and check this message digest on all the switches. You may see one or two switch having same message digest. Then check whether that two switch has got all the necessary VLAN configured already. If yes, then try to match the other switches with this one in domain name. So this two switch has got a domain name. Put the same domain name on all other switch and see whether the replication happens. If not, check whether the trunk links are properly configured between those switches where the convergence has not happened. When you fix these two, you should see all the VLANs replicated. If not, try to create one VLAN and delete the same VLAN. Then the VTP may get refreshed and start replicating. Even if you do this, if the replication is not happening, what we have to do? There may be a password. On those two switches, check whether any password is there. This is the command to see. Show VTP password. And you may see some switches with password, the others not. So try to put the password on one switch to all other switches. Or if some switch is configured with the wrong password, try to know the right one. How do you know the right one? It will be there in the question. If it is an exam, it will be there in the question. They will say, this is the password. And check whether that password is there. Sometimes, instead of O, they will put 0. Sometimes instead of 1, they will put L, lowercase l, in the password. So those things you need to carefully watch. And when you fix the password issue, then message digest all will match and you will see VLANs getting converged. That is how we troubleshoot VTP. In the early days, CCIEs were with this VTP troubleshooting as the first question. Even now, it should be there. VTP troubleshooting will be always there in CCIE exams because there is no big question to ask in CCIE layer 2 concepts. Layer 3, you have a lot of topics to test, but in layer 2, you don't have much topic. So VTP, they always use one of the layer 2 topic. Mostly it will be the first question they ask to troubleshoot VTP. But I have not seen version 3 VTP asked any time, but version 3 is also very interesting. Now, we got this server mode everywhere and all are fully synchronized. At this time, if I delete a VLAN, show VTP, show VLAN brief. If I delete a VLAN, let's say I'm not deleting, I'm going to change the name of this. VLAN 200 name, I say 2. Even this is a modification cost. And I'm expecting, earlier the revision number was what? 6. Now it should be 7. It is 7. But the existing VLAN is still 10. but the revision number is changed. I'm expecting that same status on the other switch. This is on switch 3. If I check on switch 4, that is enough. Earlier it was 6, now it is 7. You see, the message digest also changes and it matches with switch 3. Switch 3 is 71, switch 4 also 71. Even the modification impacts, gets replicated. Now, deleting VLAN will also increase the revision number. Let's do that. No VLAN 888. And if you now go, the existing VLAN should be 9 and the revision number should be 8. Let's verify. Yeah, existing VLAN is 9 because I removed one VLAN 888 and the revision number is 8. Let us go and check this message digest 60 on switch 3. Switch 3 message digest, yes, 60, which means this is correct, synchronized fully. Now what is next is the client. I'm going to make switch 1 as a client. VTP mode client. And I'm going to make switch 2 as a transparent. VTP mode transparent. See, as soon as I say transparent, what you can expect is the revision number will go to 0. But the VLANs that are already there will not be removed. Will not be removed. Let's verify that. Show VTP status on the transparent switch. The VLAN is same, but the revision number has gone to 0. Show VLAN brief. You still have the same VLANs, but the revision number is 0. Now I'm going to create VLAN here, VLAN 999. It gets created, but it will not increase. See, 999 is created. It will increase the existing VLAN, but it will not increase the revision number. It has increased the existing VLAN, but no revision number increase. As a result, no VTP will be sent. If you go to switch 4, there is no change, you see. There is no change. And here the message digest is 60. And on switch 2, which is a transparent switch, the message digest will be always this if you don't do any configuration. And that 60 will be there on switch 3. Switch 3 message digest will be matching with switch 4's message digest. Now on switch 3, this is a client. Switch 3, it's a client. I cannot create anything. But when I try to create, see what happens. VLAN 770. It says, hey, you are not allowed to configure in the client mode. So I'll go to a server. Which one is a server? VLAN 770. I am expecting existing VLAN to be 11. Sorry, earlier what it was? Earlier 10. I think somewhere before when I deleted, I did not come and verify. So show VLAN brief. The 777 is there. Yeah, 888 we removed. We did not come and verify. That's why it was not updated. Anyway, revision number got incremented. That is what very important. The revision number from 8 it has turned to 9. See, earlier it was 6, and then after that we did not check. Now only we check. It's 9. Let us check this message digest now on switch 4. Switch 4, I'm expecting 55. Yes. I want to check on the client, which is switch 3. Client, what's their message digest? That will also have 55. But the transparent switch will not have any change. It is still the same 0. Show VLAN brief, there is no 777. There is no 777. So what do we understand? When I created 777 on switch 1, transparent switch was forwarding it to switch 4 without synchronizing its own database. And when I created 999 on transparent switch, it did not send any update to anyone. And the revision number never got incremented. So this is one of the way in which you can make the revision number 0. By deleting VLANs, you will not be able to reverse the revision number. So it's a good practice to make a revision number 0 before you connect to any other existing topology. If you're connecting a switch to any other existing topology, reset the revision number. The best way is remove the domain name, that will also reset the revision number, or just make it as a transparent mode and then make it a server mode. When you make it as transparent mode, it becomes 0, and make it a server mode again, and then you connect to the existing topology. Whatever is there as a revision number, the existing topology, that will get copied here. Okay, do you have any question on server, client, and transparent?
Yes, sir. So basically, in client mode, you mentioned that, we cannot create, delete, or modify. Now, in an enterprise environment, because, the switches are up for years normally, isn't it? Like very rarely the switches goes down, or maybe when there's an update, firmware update or something like that, the switch gets rebooted. Now, when you say it's saved in the temporary memory, now, as far as the switch is up, the VLAN configuration will be same as the the switch in server mode. And now when switch reboots, it will basically remove all the VLANs. When it comes back up, it will basically sync with the
Correct.
server, isn't it?
That is right.
Okay. Okay. Great. So, and the other thing is, now in the message digest, now there are a lot of different figures.
They are
Now,
generated by
is there any way like,
using the number of VLANs,
yeah,
and then the password, the domain name, all these things. They are generated by taking the VLAN
yeah,
number, the password, and the domain name. Three things: domain name,
okay, yeah, that's all, sir.
domain name,
Right.
password, and then the VLANs. Even if I change the password, the domain name will change. Sorry, the message digest will change.
Will change.
It will change. Yeah. So now let us go and see that I'm on switch 2. It's a transparent switch, but you see, because I put the password here, it won't allow the synchronization. It won't receive any update to pass. See, even though it is transparent, it will authenticate when a VTP update comes. Only if authentication is successful with the neighbor switch, it will accept the packet and forward it to the downstream. See, I'm going to say VTP password 1, 2, 3. After saying that, I'll go to switch 3 and configure VLAN. Already we have 10 VLANs. Now I'm saying VLAN 2 to 2. Sorry, this is client. Let me go to server. VLAN 2 to 2. Now this 2 to 2 will impact switch 3. You see 11 VLANs. Message digest is 8B. But it will not impact switch 4 because the middle switch. What? Okay, sorry, I changed my version. I know there's some point with the transparent and password. Okay, this is the one. In transparent switch, whatever the password, that doesn't matter. That doesn't matter. Sorry, that's what actually I want to say. the password that you have in transfer switch, that doesn't matter. But between the switch 2 and switch 4, your password should match. So now I'm going to go to switch 1 and configure VTP password AKJ. Now I'll go and configure the VLAN 333. It is going to impact locally, but none other switches. 612, show VLAN brief is there. Yeah, 333 are created.
It won't be
Yeah,
replicated, isn't it,
password
because of the password?
mismatch. So here, if you see the message digest doesn't match. Here still it is 8B, whereas in router 1 it is 52. So password matters. And now when I go to switch 4 also, I won't see. It's still the same 8B. But on switch 4, when I change the password to AKJ plus VTP password, is it AKJ I gave? Yeah.
AKJ, isn't it?
So now I'm expecting on switch 1 when I say VTP, sorry, VLAN 111, I'm expecting the message digest 89 to match on switch 4 because it's got same password. Yes, 89, which means that 111 has come here. Yes, but switch 3 will not have. It's still a 8B. So there is no change to the VLAN database in switch 3. No 111. So it doesn't matter what password is the transparent switch. Wherever the update impacts, that is where the password should match. Yeah, this proves that transparent switch will not even open the VTP packet. It will simply pass it. If it needs to open, it needs to match with the password. So it is not even opening, it's just ignoring and passing it down. All right, so that's all about version 1 and 2. Now we need to see version 3.